Okay, so before we move on to the next part, I want to address a common issue that I see all the time. And it's really important to not make this mistake, and we're going to talk about why this is a mistake. So I'm just redrawing what we had up above, and we're going to compare and contrast the right way to draw this mechanism and an incorrect way of drawing this mechanism. So we set up above that the first step was the formation of this carbocation, and the second step was the attack of the blue oxygen onto carbon-2. And then after that, we could remove one of our hydrogens from our positively charged oxygen. So one thing that I see all the time that turns out to not be so correct is that people try to combine steps. People will try to, let's say, have a water come in and try to take off our purple hydrogen and break this bond between the purple hydrogen and the oxygen while also attacking this carbon-2. Now, there's nothing necessarily rule-breaky about this kind of mechanism. You're actually following, if you drew it this way on the bottom, you'd actually be following all of the rules in terms of arrow pushes and how to draw mechanisms. The only thing that you'd be getting wrong really is how you're utilizing water as a base. And the reason that this is an incorrect arrow push is that if you compare and contrast this top scenario, we can talk about the acidity of this purple hydrogen up above versus the acidity of this purple hydrogen down below. So thinking back to pKa's, we said that this was a pKa of approximately -2. Because, even though this is not hydronium, it's very, very similar with a positively charged oxygen versus this purple hydrogen down below. This is more like water or an alcohol, and this has a pKa of 15. So at this point, this purple hydrogen is very, 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 very not acidic at all. And when you compare and contrast this down below to this example up above, this purple hydrogen has now become exponentially more acidic. And so really it's been shown that if you had to choose between doing these two pathways, either drawing it down below or drawing it up above, the top mechanism shown up here is actually more akin to reality, which is you can take away that purple hydrogen, but you have to wait. You have to wait until you can make it acidic enough to remove that hydrogen. And so right now, if you draw your mechanism like this, where you try to combine everything and smush it into one step, that's a very common mistake. And it's a mistake because at this point, that purple hydrogen just isn't acidic enough to be lost to any appreciable degree. Okay, so try to avoid the temptation to squash your mechanisms into as few steps as possible.